All right, today we have a very brief note section just talking about inequality notation, and this is just going to help us describe some final behaviors of polynomials, and then we're going to spend the rest of the class kind of putting it all together, reviewing what we know, preparing for the upcoming quiz. So first thing we should do in our note section is just get down this kind of translation chart, right? We have a few different inequalities here, and we just want to list out what they mean. So less than, we're always kind of reading left to right. So less than has the small side on the left, the big side on the right. Less than or equal to just has that dash underneath. Greater than is going the opposite direction, and then greater than or equal to with the dash underneath as well. So we can use these signs to, sorry about that. We can use these symbols to kind of express different inequalities. So in examples 1 through 3, we're going to write in words what each inequality means. So in example 1, when x is less than 16, that's exactly how we read that. Notice how all I did was say x is less than 16, x is less than 16. Okay, for number 2, it gets a little more complicated. We have this funky infinity sign, specifically negative infinity. But again, we're just going to read left to right here. So negative infinity. So we have negative infinity, which we'll use words in this one. Negative infinity. Again, we have our is less than sign. So is less than. And finally, x here. And our last example, example 3, again, we just read left to right. Even though this is more complicated with multiple signs, we just take it exactly as we see it. So we have negative 5 is less than x is less than infinity. And another way you can say that if you want to is saying in between, if you're so inclined. So let's go the other direction now for examples 4, 5, and 6. We'll clear my selection there, move, and so we're going to go the other direction where we're given some words and we're going to write inequalities. So in this case, x is greater than negative 6. So we have our x, we have our greater than sign, we have our negative 6. For number 5, we have x is less than 12. So x is less than 12. And this last one looks like I have a typo here. Let me fix. We have x is in between negative 6 and 12. And so this one will be interesting and one that we see very frequently. We can throw x in the middle. We can put a less than sign on either side of that. And negative 6 is our lower number, and 12 is our higher number. And so this reads as negative 6 is less than x is less than 12. And all that means is that, hey, if negative 6 is less than x and 12 is greater than x, then x is just going to be in between those two numbers. So we can start using these inequalities to describe function behavior. So here's some notes you should jot down in that next section of your note page. You go ahead and pause your screen and unpause it when you're ready. But yeah, we can use these inequalities to describe function behavior for certain intervals. It specifically helps us describe increasing or decreasing behavior. And the key point here is always read from left to right. So we're just going to run through 3 examples really fast. Example 7 here. We want to describe when the function is increasing or decreasing using inequalities. So if we read our graph from left to right, we'll notice that we're decreasing, 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 decreasing in the blue. We hit this local minimum here, and then we are increasing, 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 increasing on the right in purple. And this spot here where we kind of switch over is roughly negative 0.5. We can take an estimate there if we want to. So we are decreasing. I'll put that one second. We are decreasing from negative infinity, so all the way on the left, our graph is decreasing, 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 is less than x, is less than that's negative 0.5. So what this is saying is that x is decreasing everywhere on the left up until that negative 0.5 spot, and then we start increasing again. If you want to, you can also write it just like x is less than negative 0.5 and not even include that negative infinity if you don't want to. Then our increasing, so that will happen everywhere else. So as we move right of that negative 0.5 spot, so let's bound that over there. Negative 0.5 is less than x. And we can either say is less than positive infinity, or if we wanted, we can just leave it as negative 0.5 is less than x. So let's try this on your own. In example 8, go ahead and pause your screen, and we should have 2 spots where we're increasing and 1 spot where we're decreasing. So as we read our graph from left to right here, we'll notice this first blue section right up until that point at negative 1, we're increasing, right? So let's throw increasing on here. And we know that x is less than negative 1 where we're increasing. If we want to, we can include that negative infinity out in front of it. Negative infinity is less than x is less than negative 1. That part is definitely optional. Then we look at this next segment here, and we're decreasing from negative 1 all the way to 2. So decreasing. In this one, we're going to have to write one of those in-between statements. So bounded by negative 1 on the left is less than x is less than 2 on the right. And then we hit that minimum. So we're increasing again at that final blue interval. And that will just be negative, or this will be positive 2 is less than x. And we can either leave it like that, or we can say, hey, it's bounded by positive infinity on the right. All right, and final example here, example 9, try this on your own. Identify those increasing and decreasing spots, and unpause your screen when you are ready to go. I'll start identifying increasing here. If we go left to right, it looks like we're increasing all the way up to this spot, and that hits about negative 2. So from negative infinity is less than x is less than negative 2. Then we're decreasing until we hit 0. So let's write our decreasing. Going from negative 2 is less than x is less than 0. Increasing again from 0 all the way up into positive 2. So 0 is less than x is less than positive 2. Notice how that lines up there. And final decreasing spot here, we have positive 2 is less than x. And we can either end it like that, or we can say is less than positive infinity.